I will always try to see if I can present both sides with the same base, like here, 2 to the third and 2 squared. So, yep, the left-hand side is nice, e to x plus 4. The right-hand side, is there another way of writing this as e to a power? Which power will that be? E to which power is 1 over e to 2x? What do you think? Anyone? What do you think? E to which power is 1 over e to 2x? What do you think? Anyone, please? Give it a shot.
Is it negative 2x?
Of course. Thank you very much. Good. Two exponential notations have the same base and they're equal. What has to happen then?
X plus 4 equals negative 2x.
That's it. So I bring x to this side. So x is negative 4/3. Okay, all these were nice and, some of them required a little bit more work, but overall they were nice. Now we're moving away from nice. So moving away from nice means number 23. And I think that this is my page 7, yes. Number 23, 10 to the x equals 3.91. Well, this is no longer nice, meaning there is no way 10 and 3.91 can be presented. There is no way these two can be presented with the same base. That's not possible. Well, I have to think in terms of when just for a second, an analogy here. When we had the square root of x equals 2, what did we do to both sides to solve this equation? Anyone remembers? What did we do to both sides to solve the square root of x equals 2? What did we do? What do you think? Anyone remembers what we did? Well, we used the inverse function. We had to square to get x equals 4. The same thing here. We have to use the inverse function. So here we applied the same thing to both sides. Here we have to apply the same thing to both sides. Because the base is 10, I will apply log, common log, to both sides. Why? Because if two numbers are equal, their logs will be in the same base. Their logs will be equal. But by applying log, I have to use a property. I can use a property, which is the power rule, and bring x down. So now this becomes x. Log base 10 of 10 is 1 equals log of 3.91. Of course, I can approximate. Put in the graphing calculator. And common log of 3.91 is something 0.5922. How do I check? Well, I raise 10 to this power, to the previous answer. And the answer must be 3.91. Otherwise, 0.592176 la 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 is wrong. I didn't mean that. I meant this. And indeed, the answer is 3.91. So that I know that I have to raise 10 to power 0.59, blah, 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 to get 3.91. And this cannot be accomplished by presenting both sides with the same base, because that's not possible. So as I said, we moved away from nice. So now we can graph. I didn't mean that. Now we can solve anything you want from 24 through 48. And this is no longer nice. We're done with nice. Let's choose, please. The most difficult one is 41, 42. These are the most difficult ones because of the steps. And 43 through 48 are a different type of equation. So for now, let's choose from 23 through 40, and then we will work on 41, 42, and we'll choose from the rest. And anyone would like to choose from 23 to 40 for now?
Can we do 31?
Yes. Very good, 31. 3 e to 5x equals 1977. Okay. The key is to apply natural log. There is no way I can present both sides with the same base, but this has to go away before I apply natural log. Why natural log? Because I see base e. If the base is 7, it doesn't matter if I apply log or natural log. But if the base is 10, I will always apply common log, because log base 10 of 10 is 1. And if I have base e, I will always apply common log. I'm sorry, natural log, because natural log of e is 1. But if a base is 7, it doesn't matter. Good. How do I get rid of this? I divide both sides by it. So e to 5x, 14, 24. What am I doing? So 14 plus 20, 10 plus 14 is 24, so it's divisible by 3. And 17, 5, and in 27, 9. Correct. Perfect. Okay, now, after I cleaned it up, dividing both sides by the factor in front of e, now I will apply natural log to both sides. I will bring 5x in front. I will disregard natural log e because it's 1. And then I have natural log of 659, and now I divide both sides by 5. I don't divide here, I divide this number. Careful. Natural log of 659 divided by 5. And yes, I can approximate it, and I can check. So let's approximate natural log of 659, everything divided by 3. So clear, natural log 659, everything divided by 3. I'm sorry, I meant 5. And now I get 1.2981. And now I want to check. And what am I checking? 3e parentheses 5 multiplied by the previous answer, but make sure that the previous answer is this and you didn't have other calculations in between. When I hit enter, I have to get 1977. If I don't, the answer is wrong. If I don't get 1977, the answer is incorrect. Okay, very good pick. Anything else would like to pick from 23 through 40?
$35.
Very good. Let's take a look at 35. 35, very good. In 35, we have e to 5x minus 3 minus 2 equals 10,476. Perfect. Like before, and like with everything, I have to clean it up. And at this point, the only thing I can do is just add 2 to both sides, or move negative 2 to the other side, it becomes positive. So e to 5x minus 3 equals 10478. Ready to apply natural log. Why natural log? Because I see base e here. Again, if I have base 7, it doesn't matter. Good. So now, careful. The power comes in front as a factor, which means if I don't put it in parentheses, then it's wrong. The reason I wanted to show this is because sometimes the base will be 7, and then I have to write this. Yes, you can say you didn't have to because this is 1. True. But no matter what, when I have an expression like this and I put it in front, it has to be in parentheses. Now there is no need because this is 1. Okay, so then we have 5x minus 3 equals natural log 10478. No one can change this. I will add 3 and divide by 5. So x equals natural log 10478 plus 3 and everything divided at the end by 5. Yes, I will approximate it and check. Be very careful because we need parentheses around the top. And then divide by 5. There is no need for parentheses in the denominator. Okay, so let's see. So parentheses. Do not perform the operation step by step. Put everything in the graphing calculator as you see it, plus 3, and then directly divide by 5. Good, so the answer appears to be 2.4514. Okay, I want to check. How do I check? E, in parentheses, 5 times the previous answer, minus 3. Close the parenthesis. Come down from there. Close the parenthesis. Why is it not? Okay. And then minus 2. And if the answer is not 10476, my answer is incorrect. 10476. But remember, in order to use this feature with a second and answer, you have to have this, the last operation you performed. Otherwise, it will use something else, not the previous answer. Not what you need, but the previous answer in the calculations. Good. Anything else before we look at 41? Did we get the idea? Well, let's also look at 39 before we look at 41. So in 39, we do have 7 raised to 0.3x equals 813. Okay. So it doesn't matter what you want to apply here because the base is 7. Natural log will do the same thing. exponent log, common log will do the same thing. So it's easier to write ln versus log. So I prefer natural log. 0.3 x multiplied by natural log 7 equals natural log 813. I have to divide both sides by this product. So then x equals natural log 813 divided by 0.3 times natural log 7. Careful how you enter this in the graphing calculator, because they're all products, so you could skip certain steps, but I recommend natural log 813 close, divide, and put the denominator in parentheses. 0.3 times natural log 7. Close, close. Press enter. So approximately 11.4783. Do not use the approximation to check, but just say 7 power in parentheses 0.3 times the previous answer, because it's right here above. And when I press enter, if I do not get 813, then the answer is wrong. Any questions on 39? Okay, let's look at 41. I claim that 41 is the most difficult. And here's why. Because of the steps. So in 41, we have 5 raised to 2x plus 3 and 3 raised to x minus 1. There are a few steps in here that you have to be very careful with. 5 and 3, no way. This is not nice. So I'm going to apply natural log, as you know, to both sides because I need to bring the power down, and I have to put it in parentheses, as we discussed a few minutes ago. X minus 1 has to be in parentheses. But now in order to solve for x, first I have to distribute natural log 5 to these two and 3 to these two. So 2x natural log 5 plus 3 natural log 5 equals x natural log 3 minus natural log 3. So far it was just algebra from here. But now notice one very important thing is that this term and this term, these are the terms with x, and they have to be on the same side. The term without x has to be on the other. So I have 2x natural log 5, but minus x natural log 3 equals negative 3 natural log 5 minus natural log 3. These are not like terms, but I still have to solve for x. What should I do to these two terms in order to solve for x?